Hey! Hey, Golmash! How we doing? How we doing, ladies and gentlemen? Hopefully we're doing... Hello, hello, hello. No. It's kind of dark over here, but let me adjust the lights here. Hang on. All right. Let's go to the big face cam. Hello, 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 everybody. Good, just chilling. Good, Golmash. All right. Hello, 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 everybody. I hope everybody is doing absolutely fantabulistic today. Hopefully everybody is pretty chill today. Yosin, my dude, what's going on, my friend? How you been today? How was your weekend? Actually, how was everybody's weekend? I should ask Jess and Gemma and Golmash and Yosin. Hopefully you had a wonderful weekend, a nice long weekend for us in the U.S., but 4th of July is Independence Day here in the United States. So, the day that the Declaration of Independence was signed was the 4th of July, 1776. Weekend was great from Canada. You don't have American Day. Hey, look. They don't have American Day, but you have like Boxing Day, okay? You got every day is like Timmy's Day, okay? Where you can buy some Timbits for like $1.05, some hot chocolate for maybe $1.55. Canada Day. That's right. Something that, yeah, look, everybody's got an Independence Day. I respect that. You know? I felt the freedom through the fireworks. Brian, good afternoon. Good afternoon. Khadija, hello. How we doing? I hope everybody is doing absolutely fantastic. I hope everybody is doing fantastic. Doing good, good. Did you have a nice weekend? Hopefully you had a nice weekend. I'm gonna try and get some. 4th was amazing. Good. Good. Glad you had a good time. That's all that mattered. You had a good time, and that's what matters here. To say. Okay. Fine then. Alright. Look at this. Look at we got 9 people already, and there you go. The 5th was spent quietly. I was trying to get my voice back. I don't get an Independence Day in the UK. That's okay. You know what? There's other holidays in the UK. I'm pretty sure. There are other holidays in the UK. So, I mean, just because the 4th of July is not a holiday over there, doesn't mean you don't have your own local and regional holidays. The UK seems like a dope place to live. I mean, for every person, it's gonna be a different experience, but I would think it'd be a pretty cool place to live for a little bit. Things are gonna be a bit more expensive if you're especially in England, but especially with the football culture there, respect. That's right. This is true. This is very true. That's what I was doing this weekend, was watching football. So, watching some football this weekend here on YouTube. Actually, on YouTube, watching a preseason game for Hashtag United. That's what I was doing. Went to Bartlett Fest and that was decent. Modern Day Romeos were playing in the back, okay. After that, it was real fun again. Went to a party with my friend. We set off all the fireworks. So fun with blast music. Yeah, there you go. Nicholas, hello, hello, hello. How we doing? Fantastic. Hope you're doing fantastic. This afternoon slash morning. Yeah, I was watching Hashtag United this weekend. That was my plan. All right. Yes. Doing good. I'm doing fantastic. You're here. I'm doing even more fantastic. More fantastical. Fantabulicious. Fantabuloso. Is it coming home? Oh, yes, it's coming home. Yes, it's coming home. It's coming home indeed. It's going to be a heck of a game on Thursday, let me tell you. Going to be a heck of a game. I'm going to be watching that. After I'm done with this class here on Thursday, that's the first thing I'm going to switch on my TV, be like, well, my pseudo TV, and I'm going to be watching that match. Denmark, England, for the spot in the finals. That is going to be a heck of a match. I am going to be super excited. They played so well against Ukraine. Like they played like a club that had the energy and pace. It just destroyed Ukraine. First minute on, it was just a barrage. It is going to Italy. I know you're a naysayer of England, so I'll let it go. I'll let it go, Goldmash, since I know you're a little bit salty that your team didn't make it. So totally understandable. Didn't Italy lose one of their players to an Achilles injury? So it's gonna be rough. I believe they lost Immobile. So in any case, yeah, I gotta bring that up. I forgot about that. Let's go and bring this up here. Guys, we have a short week this week, if you can believe it. So just meeting 3 days this week instead of the requisite 4. But drink of the day is still Dunkin' Donuts coffee. I needed to wake up this morning because I was feeling tired. Like, I gotta get coffee. I don't have any drinks in the house, so I gotta go out and get some. I only got this and like a little bit of water left, so all the rest of my drinks are gone. So I need new stuff for sure. Just like hydrate anyway. I said okay, that's fair. Sure I didn't post that up yet. I can't believe there's either 2 weeks? No, there's 3 weeks. 3 weeks. 3 weeks to go. Like 2.5, 3 weeks to go, Khadija. So after this week, that'll be 3 more weeks. We're halfway on our last class there. So we're all in 29th is the last day of this course. All right. If I tell myself 2 weeks, I'll work faster. Okay, then I'll tell you it's 2 weeks. Okay. Yes, that's something I do need to talk about here. Lysidena! Good afternoon. Thanks for bringing that up, Brian. That's something I definitely need to talk about. 100%. Let's move this out of the way. Oh gosh, you don't want. Alright. No? Wrong way? There we go. All right. And let me check this. If the music is too loud, just let me know, okay? And I'll turn it down. Okay. Just keep saying it's the last week you can speedrun your homework. All right, ladies and gentlemen, let's go ahead and get started here. We got some things to talk about here. Got some things to do. We got there's some things to be had, some fun to be had, hopefully. Let's get going here. Some intros and the whole 9 yards. All right, let's do it, ladies and gentlemen. All right. Okay, let's get started today. Welcome back. Welcome back to Tuesday. Hopefully, a nice 4th of July weekend. All right, so again, hopefully everybody enjoyed the weekend. Hopefully everybody enjoyed just sitting, chilling, enjoying some fireworks, having a blast, having a great old grand old time here. We're going to start off here on a slightly different note instead of starting where we left off last time. I did work a little bit hard here yesterday, just a smidge. You know, I actually was working. I know, it's rare for me, but just gonna put this up here for right now. I have effectively made what I've effectively done here is I've effectively made up the all the practice tests and all the regular tests. So I've gone over here from chapters 1, 2, 3, 4, 5, and 6, and 7 and 8. Now, just to let you know here, there's a couple of things I do need to discuss about this. Yeah. There's a couple things I need to discuss about this. At least let me tell you my motivation for doing this over the weekend. Number one, the 29th is coming up here in 23 days, so we need to have this up by now. That's number one. Number two is this last test that I do need to talk about, and that is the chapter 7 and 8 test. We'll see how far we can get here in terms of the material. We should be able to get through most of the material here without too much trouble. But if we don't get to chapter 8, I'm going to be omitting sections from chapter 8 if we do not get that far, or if I do not feel comfortable with the amount of time you have to process chapter 8, then I'm just going to strike questions off of chapter 8, or again, just strike the entirety of chapter 8. So if we just run out of time, or I don't feel that there's going to be a lot gained out of it at the very last minute. So I'll certainly let you know if that's the case. I just want to let you know here. Now, in relation to that, because there's one more implication in relation to chapter 8, and in case if this happens, let me go ahead and showcase this off here. What I have effectively made is I've effectively made a final exam. All right, so this final exam here is basically has been pretty much culled and pretty much factored in and everything like that. Everything has been put together for the final exam. All right, so there's no surprises for the final exam. Now, the final exam does contain questions from chapter 8. So the way it's going to work is if I don't feel that we get through the material there for chapter 8, I'll be just striking out the questions here from chapter 8 and leaving all the rest of the questions behind. Okay, so that's really what the story is for the final exam. So I was thinking if I should post this today or not, because I do have it pretty much done in terms of all the material I would like on there. Everything is pretty much set in stone for the most part. So I could just go ahead and assign this. I will let you know about a couple of things here, though. I'm going to go to the settings here so I can show off a few things. First of all, everything is pretty much the same. I'm going to, of course, increase this time allowed of 600 minutes. This time of 600 minutes will be pushed up a bit, so I'll just put 720, and then that should be okay. All right, so let me save that here quick. All right, secondly, is also the amount of questions here. So the amount of questions here is going to be longer than the exam. Okay, longer than a regular exam. So the amount of questions here is going to be 90. All right, so there's 90 questions for the exam. All right, so 90 questions for the exam. Very straightforward. Nothing too crazy. Now you're probably saying, wow, that's a lot of questions. I'd be like, sure, that's a lot of questions. To be fair, I'd be like, okay, you know what? You're not wrong. Okay, you're not wrong. 90 questions. Brian's like, wow, that's a lot to do. We're actually gonna open up this final exams for you guys, so you'll have that available. Now you're probably saying, now hold up a second. 90 questions is a lot, and to be fair, you're not wrong. Okay, but let me go ahead and tell you, are there multiple parts in a question? Yes. Yes, there are. Hence why I'm giving you 12 hours of which to finish. Okay, so like I said, no surprises, no nothing. Everything has been pretty much set apart. Is saved for later. Get 5 attempts, get the best thing on it. You know, that sort of dealio. Alright. But I want to at least tell you about these questions here. First of all, where are these questions coming from? Okay. All final exam questions are from the pool of regular exam questions. So I literally had to do it in like 2 stages because you can't fit more than 150 on a list for my math lab. So I literally took a pool of like 180 questions. Okay. I took a pool of 180 questions and then I narrowed it down to like 90. So I cut it off by 50%. So I had like that's basically what I did. So all the questions that were for every single one of these exams, I then took a pool of half of them, and then I went ahead and made up a final exam based off of that. Okay, so that is what the story is for the final exam. So again, give yourself plenty of time in which to finish the final exam, number one. Number two, you notice that there's no practice for the final exam. It's because all the questions for the final exam are from the previous exams themselves. So if you do the practice exams, okay, for all the chapters, you'll have all the similar type of questions that you'll see there on the final exam. All right, so you're just basically putting it all together at the end of the day. Some questions will go fast, some questions will go a little bit slower, but you have 12 hours of which to finish in 5 attempts. Should be plenty of time of which to get it done once we get past certain points here. So, are there any questions about the final exam here? All right. The practice exam grades are factored out already? Yes, they are, Brad. I made sure to factor those out. Yeah, I forgot to edit this. Forgot to take out the time frame for the practice. There we go. Yeah, so those will be factored out automatically, Brian. So those will be factored in as bonus points, just like I mentioned here from before. Okay, so when I put together the final grade book for your final scores at the, after the 29th, I'll have a lot to do because I'll have a lot of grades to enter in. I'll have that'll be factored out, of course. It'll just be your actual test grades. I should have already omitted it from your grade book, so you should be good to go there. Which is a friendly reminder here, by the way, you probably if you checked out your midterm grades, yeah, I just gave everybody a B, so I'm like, everybody gets a B. So don't be surprised everybody got a B. It was pretty much straight across the board. It wasn't a bias toward anybody. So because everything being up in the air until the end of the semester, I had to give a grade. I'm like, all right, everybody gets a B. Here you go. So midterm grades literally mean nothing because it's a self-paced kind of course. So, any more questions? Any more questions about anything up to this point? Very important we get things down transparently so we know exactly, you know, what's going on for you guys, and I want to be sure that you guys are kept up to speed about what's going on my end of things. I have a lot of work to do at the end of the semester, don't get me wrong. But everything now I've actually posted up the final exam. Everything now should be available for you to go ahead and do and start. Okay, so now you can have the last month here, last 3 weeks to get things finished and get things done. Okay, again, you got till midnight of the 29th. Be sure to save your work, of course, and be sure to get that stuff done. All right. Okay, so we're gonna go ahead and if there are no more questions here, we're gonna go ahead and move forward here from where we left off last time. Last time we talked about substitution and elimination in a system of equations. Thanks for doing this. Yeah, no problem. Look, it's what it. I think it's what a teacher gotta do. uh, I told you from day one, Jess. I gotta be transparent. Told you that's day one. If a teacher's not transparent with you about how they're doing things, then that's not a good sign. Okay, that's not a good sign. Because thing is, if this is a class and you want a grade, it's got to be crystal clear exactly about how things are done with that particular teacher. It's me, okay, or it's someone else. You have to, if you're unclear about anything on the syllabus, anything that's subjective, you know what? You gotta ask, and you gotta demand, be like, hey, look, I'm paying money for this class or whatever. You know what? I need transparency about how, you know, what your expectations are. I just decide to head it off at the pass. I'm like, I'm just gonna tell you because, you know, there's no point, you know, trying to hide it from you. I feel that's a waste of time, and I feel that just sows distrust in a class in general. So, I I think it's just easier. Everybody gets it out of the way. I tell you how I operate. Everybody knows exactly what's going on 100%. And again, there's no surprises, no drama, no nothing. You know. Hey, Gemma, welcome back. So I'm not about the drama, okay? If we want the drama, you can leave drama to Love Island or something like that. All right, that's drama. All right, but I don't need drama in my classes. That's the last thing I need. All right. You know, this is just a stepping stone as part of your life. We don't need the drama. We want to get things done. So now the onus is on you to get things done, and so that's what we're working with. You know. All right, ladies and gentlemen, let's go to the handout here. Look, the one thing you don't need in your life, okay, is like an unequitable amount of drama. Okay. Look, I've dealt with drama a lot of my life. I don't need the drama. It's brutal. Thank you, Khadija. Drama is just terrible. I'm too old for drama. I know. I'm like, look, high school was a long time ago for me, alright? I graduated in 1997. I don't need that crap no more. I just need to do what I need to do in order to get by. In order to survive, in order to do what I need to do. So, there you go. Alright. You guys, the heck. Alright, thank you guys. Alright, guys. We're gonna start this lesson here. Alright? All right. I'm gonna drown in coffee here. All right. Otherwise, I do have to start this lesson eventually. Wait, serious question. What are those things? I was new to Twitch until this class. Oh, that's the channel points that you have. So the longer that you stay here. Okay, so click on the. Yeah, so click on the. So let me show you my screen here. Okay. So on the chat box, if you click on this icon down here, which is the green sigma, which represents the channel points here, if you just click on that, and then you can redeem those channel points you've collected over time, and you can see some of the things that I have here, like posture check or hydrate or say something nice or thumbs up or something like that. So those things you just click on that, and then you can confirm, and then you can redeem points, and then there you go. You can redeem the points. Just like that. I can control the amount per item, yes. That's done on my end. But yeah, it's a good way to interact or whatever. So that's how you can go ahead and do that if you want to interact. Yeah, no problem. I know some people are new to the platform or something like that, but yeah. You want to go searching around in other channels, and the more time you spend on a channel, the more channel points you collect. If you sub to that channel, you'll collect even more channel points. But every streamer has their own different metric about what you can do with those channel points. But channel points are completely free. Okay. They'll give you like a little bonus every hour for like every half hour or whatever for just sitting there. But yeah, it's just a nice way to interact with people. Are the points per channel? Points are per channel, yes, per channel. They have their own unique, because they each have your own unique channel, so you have your own unique set of channel points per channel that you go to. That's correct. All right. Yeah, no problem. I'm here to help. All right, ladies and gentlemen, we gotta get moving here today. All right, so today, what we are going to be doing here is we are going to be solving nonlinear systems of equations, okay? That is section 5.4. Nonlinear systems of equations. All right. So we're going to do questions 7 and 8, which have the same exact answer. Now, the only thing about 7 and 8 is that we just want to be able to look at the problem here. We're going to take a look at different types of problems here and be able to use substitution and elimination in the same exact manner that we did here last time when we had linear equations. So, number 7 here, how do we solve a nonlinear system by substitution? We do the same steps as linear systems. So again, find a variable to equal to, substitute it, find solve for one variable, solve for the other. Now, the important part here is the note, okay? So the more important part here is the note, because that's going to be the big key difference here between nonlinear systems and linear systems. In a linear system that we talked about here last week, we had one x and one y value. Or again, we had the values of no solution or infinite solution, okay? In this case here, we can have multiple answers. So there could be more than one answer here. We could have 2 answers, 3 answers, 4 answers, whatever, all right, just depending on the situation that we're given here. All right, and the same thing goes with nonlinear systems by elimination. Now, of course, it depends what type of problem we're given will determine basically what type of method that we're going to use. So some cases we're going to be we're forced to use substitution, and some cases we're forced to use elimination. This is 5.4, Fritz, 5.4. So let's go ahead and take a look here at an example, several examples here of using both systems, both for nonlinear systems with substitution and nonlinear system for elimination. Okay. Yeah, number 6 I kind of left blank because I'm just going to show you an example there. So I'll see example. Sorry about that. I promise I'll show you an example here. No, Lisa Serena, I kind of missed that myself when I was typing out my notes. we'll just ad lib. um. All right. Let me see. Which one should I do? All right, that one looks. That makes me feel better. Good. Makes me feel better too. All right. So here's a nonlinear system. Let's do this one first. Okay. So let's go ahead and take a look at this particular example. We have x squared plus y squared equals 5, and we have 3x minus y is equal to 5. Okay. Now in this case here, let's just take a look at it from a surface level point of view before we do anything else. All right, so the method we want to choose here, if a problem looks like this, is we're going to use substitution here. Okay. Which number did the note switch to 5.4? Number 6. All right. All right, so we're going to use substitution here. So substitution is going to be pretty simple here. Substitution here is, again, we want to go ahead and solve for one of the a variable in one of these two equations. Now, obviously, as you can tell, I'm going to choose to solve for y in equation number 2. Okay, because y is kind of sitting by itself, I want to solve for y in that second equation. So let's go ahead and do that here. We'll have 3x minus y equals 5, and we'll solve for y. So again, the same exact process, okay? So I'm not doing anything different that I was doing from last time, okay? Nothing is changing. Again, just be a little careful here. You have a minus y here. All right. So you divide by -1 everywhere. So here we have y is equal to -5 plus 3x. Okay. Now, we need to do the same thing here. Again, just like we did last time. We're going to take that -5 plus 3x. We're just going to plug it into that y in that first equation, just like so. So again, we have to do substitution here. We don't have a choice. If we did like, the problem is if we did elimination, we would have two variables, and that would be a problem. There's no way we can actually eliminate a variable. So you can see here, this would be, again, this is like a case where you know, elimination in a linear case is super easy, but in a nonlinear case is not always the obvious choice. Okay, so let's take a look at what happens when we substitute. This is where the important part, this is where the next important part comes in. So after we substitute, we get this. We get x squared plus, and now we substitute the -5 plus 3x. So that's -5 plus 3x quantity squared. Remember, anything we substitute, we put parentheses around. That equals 5. Okay? And now all we have to do is we need to FOIL that out, and we need to go ahead and solve for x by doing some stuff. Let's see what happens. All right, if you need to do a little side scratch work here, then you can. Again, -5 plus 3x times -5 plus 3x. If you're not sure what that comes out to be, -5 times -5 is 25, positive 25. -5 times 3x is -15x. 3x times -5, another -15x. 3x times 3x is plus 9x squared. So here you get 25 minus 30x plus 9x squared. Okay. So here we have, excuse me, x squared plus 25 minus 30x plus 9x squared equals 5. All right, let's add up our like terms, see what we get. We got x squared plus 9x squared, that's 10x squared. Minus 30x plus 25. I'm just going to write this in ascending order. Equals 5. We'll subtract by 5 on both sides. Again, our goal is to solve for x. So far, this is what we have here. 10x squared minus 30x plus 20 equals 0. Okay. So far, so good. All right. All right. Any questions so far about that? No? All right. Can anybody tell me here what I should factor out? What can I factor out of this equation before I actually put this together? What can I factor out? 10x squared minus 30x plus 20. Yep, that sounds perfect, okay? Excelente. So let's put out a 10 there. Alright, so we take out a 10, we're left with x squared minus 3x plus 2. Alright, much more manageable numbers, at least in this instance. And now we just go ahead and we have to factor the parentheses here, so we're going to get x minus 2, x minus 1. Okay, so two numbers that multiply at plus 2 would add up to minus 3. So notice what's going on here. Okay, so let's slow this down here. All right, so we got it factored down. Notice that we indeed have two answers for x, okay? Like I said, multiple answers are certainly possible here doing these type of problems. All right, so here we have, again, x is going to equal, let me actually put it over here. So in this case here, the implication is that x is equal to 2 and x is equal to 1. Okay, so we got two answers for x here. Now, because we have two answers for x, that means we're going to get two answers for y. Okay, again, there's going to go corresponding here. 2 is going to have its own y, 1 is going to have its own y, and those two are going to be our answers here for this particular problem. All right, so what we want to do is we're going to take this y that we had here from before. Okay, so this minus 5 plus 3x. So let's do x is equal to 2. Y equals minus 5 plus 3x. So y here is equal to minus 5 plus 3 times 2. So that's equal to minus 5 plus 6, which equals 1. Okay, and then that's for this one here. Now for this one, x equal to 1. Y is equal to negative 5 plus 3 times 1. Okay, that equals negative 5 plus 3, which equals negative 2. Okay, so we're going to have two answers here. First answer here will be 2 comma 1. And the second answer here will be 1 comma negative 2. All right. All right. Any questions about that? All right. I want to be sure I'm doing the right one there. That's fine. All right. Fine. Okay. Right. I'm going to look at another one here. So again, hang on to your hats here. A lot of different looks here for these type of problems because there's different types. Again, where we have to use the certain methods. So we're doing substitution here so far, okay? But we're still going to keep in the same vein here for substitution. All right. So again, now that you've seen the process here doing one problem, let's go ahead and try another problem here where substitution is still required. Okay. Alright, so I'm going to erase this and we're going to move on. Alright. Okay, so next problem here. Alright, there we go. Alright, so we have xy is equal to 3, x squared plus y squared is equal to 10. Okay, now in this particular case, we are also going to need to use substitution in order to solve for x and y. Now the answer for this question here isn't that hard. You can probably figure it out logically or just guess and checking. But I want to show off the process here at least about how to get to those results, because, well, homework problems could have very different numbers. It could be uglier. So in any case, so I'll have you guys pick here. Which equation are we going to use, and which variable are we going to solve for? You can literally pick either variable, but the equation you want to use is going to be important. We're going to use the top equation. I agree with that. And you want to solve for y. Okay, Brian. Absolutely fine. All right, so let's use equation 1 here. xy is equal to 3. So that's fine. All right. You can solve for either x or y. In either case, you're going to end up with the same results for your answers here at the end of the day. So I got to solve y first, so we'll just solve for y. We'll just divide by x on both sides. So y is equal to 3 over x, okay? So we're fine there. Y is equal to 3 over x. That's perfectly fine. So we're going to take this 3 over x. We're going to plug that in for the y in our second equation. And draw my arrow. That goes right there. There you go. Okay. So let's put it together here. Let's see what we have. Let's take stock. We've got x squared plus 3 over x quantity squared equals 10. Okay. Okay, so let's square 3 over x squared. Now, if you square that bad boy, you get 3 squared over x squared, so that's going to be 9 over x squared equals 10. All right? Okay. Right. So far, so bueno. All right. So let's take a look here at what the next step is going to be. Now, of course, you look at this and you're like, oh man, what do I do next? How do I make this, less terrible? I'd be like, bruh, you can make this less terrible, I promise. All right, so there are certain ways that we could do it. Okay, so let's see. There's a couple of ways that let's see, which way do I want to do this? That introduces an extra thing, so I don't want it that way. I'm thinking of 2 ways to do this out in my head, and I know which way I want it. Which way I think would be easier for you guys. Yeah, let's do it that way. Alright. I decided. I made executive decisions in my head. Alright. So the way you probably would want to do this out is, in order to avoid confusion here, what we're gonna do is we're gonna just we don't like the fraction there, okay? The fraction makes us feel bad, okay? So in order for the fraction to not make us feel as bad, well, does that actually help? I guess that does actually. Okay. Alright, so we'll subtract 10 on both sides here. Alright, so we're going to have x squared minus 10 plus 9 over x squared. And you're probably wondering why I'm doing it this way. Do have a reason for doing so here. All right. So this next part here may seem a little confusing. Now I'm still internally debating. Oh man, internal debates. I still get the same thing, right? Yeah, okay. All right, I still get the same thing, so let's do it that way. All right, so the way we want to do this is, I don't like that x squared in the denominator, okay? The x squared in the denominator makes things really awful, okay? So I don't want that at all. I just want to get rid of it. So the way we get rid of it here is we're going to multiply everything here by that denominator. We'll multiply everything by x squared. Now, I want to be clear here about this, so that way it's understood what you guys need to do here for this step. So note, I am multiplying by x squared on the top only, okay? So I'm not doing that common denominator stuff here. I'm just multiplying straight up on the top only, every single term by x squared. I can get away with that. As long as I'm equal across the board, I should be fine. Okay, so what I have here is I have x squared times x squared minus 10 times, well, minus 10 times x squared plus 9 over x squared times x squared. Okay, this is what I got. All right, equals 0 times x squared, which effectively is nothing. All right, so if I look at this here, I get x to the fourth minus 10x squared. And these x squareds, they'll cancel out. So that leaves me with a plus 9. And that equals 0. All right? So this is what I have here so far. Let me know if you guys got any questions about that. So I took a little shortcut there, so that way it made it a little bit easier to digest. Now, what comes after this is also equally as important, is what this factors to. Now, you do have an x to the fourth and minus 10x squared plus 9. And you're probably saying, whoa, that looks really complicated to go ahead and factor. But actually, what's really nice about this is that this actually does factor rather nicely. Now you're probably saying, whoa, 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 how is that even possible? You start with something like x to the fourth. Well, in this case here, you have an x to the fourth followed by an x squared term followed by a number. Now imagine if you did a little substitution here. Let's say I did a little u substitution. Let's say I set u here is equal to that middle term of x squared. We did this before here when we talked about exponential functions. We did it very briefly, but it is going to be relevant here in this case. Meaning to say, if we took u squared, that's going to be x to the fourth. So essentially, you have u squared minus 10u plus 9 equals 0. Now factoring that is really easy, because that actually turns into u minus 9, u minus 1. And then you could just substitute back in whatever you defined u as. In this case, this happens to be x squared minus 9 and x squared minus 1. Okay. So before we move on, I'm going to be slow on this part here. Are there any questions about how I got that? I hope this part here is a bit clear about how we got that. I just made up the letter here. So I said u is equal to x squared, so I made u is equal to this middle term here. So that's where that that's why we call it u substitution, Jessica. So you could make up literally any letter that you want there, to be fair. But you could, again, u here is equal to x squared. I made it equal to that middle term. That way, the factoring would be a little bit easier to see. As you can see, that's why you get u squared minus 10u plus 9. And then factoring that is super easy after that, because you just need two numbers that multiply to 9, and then add up to minus 10. So you can just say a letter cubed can be a letter squared. I'm not sure what you mean by that. Oh, you're talking to the fourth here? Yeah, so u squared is x to the fourth. The reason why is because if you set u here is equal to x squared, well, isn't u squared equal to x squared quantity squared? So that would equal to x to the fourth using exponent rules. As long as you define what your u is beforehand, then you have to put it in terms of what you substituted in as. So you have to justify it, of course. You can't just randomly say this is equal to that just because. Now you gotta justify it, but here, that's a justification about why I can claim u squared is equal to x to the fourth. It works out mathematically, Brian. So that's why I'm doing it that way. Okay. The full equation like the beginning. Okay, here's the beginning equation here. I'm gonna be throwing my laptop with this homework. Now, less laptop throwing, okay? All right? I know there are lots of walls with lots of holes, okay? No, with indentation marks, okay? But I promise you this isn't one of them. Any other questions before we move forward? Fritz, I hope you got that there. That's the full problem there. Yeah, just like zoomed out. We're not done yet, by the way. How do I justify the u thing? I justify the u thing because I would just want to make it easier to solve. That's it. So if I just want to make it easier to solve, that's my justification. That's it. I justify my u thing in terms of the middle term there. If you guys have to recall here, we did this when we first talked about exponential functions and how we actually solve for exponential functions. There was one example that actually used u substitution here in this case. We are going to use that same trick here in this instance. So Luffy, you take a look here, all right? I want you guys to be very careful about this, okay? What did I set u equal to? All right, so I set u equal to x squared, okay? So if I set u is equal to x squared, then I have to say, okay, what's u squared equal to? Well, that's x squared quantity squared. And x squared quantity squared is equal to x to the fourth, okay? So that justifies why I can call u squared x to the fourth, is based on the definition that I have for u. All right, so again, I can't just automatically say, oh, magically this is equal to this. I'm going to justify you to say, hey, this is why u squared is equal to x to the fourth, okay? Because, again, this calculation over here, I want you to kind of focus on, the part I want you to focus on here is if you want to talk about justification for u squared, and this is what I want you to focus on there, about why I can write u squared here in terms of x to the fourth. Like why I can change x to the fourth to u squared. Okay. Again, it always goes back to the definition of u and then seeing what you can do with that. The u is fake and we're just using it as a workaround substitution for x. That's correct. Essentially, okay, so let me get your opinion here. I'll ask Luffy and Blink and yourself, Jess, and everybody else. Okay, which would you rather work with? Okay, let's answer this question here. Let's just throw it back for just a second. Answer this question first. Which would you rather work with? Something that starts with x to the fourth or something that starts with x squared or u squared or whatever? You know, which way do you want it? Do you want it as a fourth degree polynomial or do you want it as a quadratic? That's the question I'm making to you, all of you. Would you rather work with a quadratic or would you rather work with a degree 4 polynomial? Because that's what I'm basically trying to do with the u substitution. Is I put it in something that's in easier terms. I would want it in a quadratic, right? Yeah, exactly, right? You would say that if I have it in a quadratic form, I have more tools available to me than if I have it in an x to the fourth form, right? That's what I'm doing here with the u substitution. If I have an ability to change it back into a quadratic form and then apply the substitution after the fact after I do all the things that I need to do, then that's what I'm doing. Yeah, I'm not doing anything super fancy here, but I'm getting into something easier and then I'm reapplying things back. So you see here, I was able to take u squared minus 10u plus 9. I can take that quadratic and I can easily factor that, right? All you need, again, is basically two numbers that multiply to 9 and add up to minus 10, right? That's all you need. And so then I just went ahead and I replaced u, which is what I defined it as, and I put it in for that. I got x squared minus 9, x squared minus 1. I swear to you, I'm not doing anything outside of that. Okay, I'm just making sure we get things down to an easier. What if it was x to the sixth? Well, if u was x squared, well then that would be u to the third power, right? Now, technically you could do this if you had, say, x to the sixth minus, here, I'll just make something up here, minus x to the third minus 2. Okay, say I had something like that. I could technically set u is equal to x to the third, and I could have u squared minus u minus 2. There you go. So, because u is x to the third. If it was x squared, let's say it was x squared, I'll write it up here. Let's say this was x to the sixth minus x to the squared and minus 2. Now, in this case here, unfortunately, I wouldn't get a quadratic. I could set u is equal to x squared again, but x to the sixth is equal to u to the third instead of u squared. Okay. Again, the reason why that happens is because here you have x squared to the third power equals x to the. So that's again, this would be pretty bad. This is a situation you don't want to be in. You never want to be in this situation. This is bad. So I want it in quadratic form, something that's more predictable. So we're not going to be in that situation. We're going to be in situations like these where we can just go ahead and plug and play, be able to use those tools that we already have available to us. All right. Any other questions before we move forward? This will only work if we're solving nonlinear systems by substitutions. Um, in this case, this is just part of the process here in solving this nonlinear system. Yes. If you have something that's bigger that you can play around with substitutions like, we saw it with exponential equations, that's certainly possible. U substitution is used in a lot of parts of math, such as calculus and whatnot. U substitution is pretty. How long did it take you to become a math wizard? Gosh. Man, I don't even know. I didn't really become a math wizard until I hit like grad school. I wasn't even a math. I'm not even a math wizard today. Let's be fair here. Let's be fair. I'm still the same idiot that I was back then. I just happen to have a title that kind of goes along with it. It's not even a title. It's a title in the name of my name of Professor Chibs, but it says like, it's a title. Nah. It's a title. I think it's just, it's just kind of like putting the logical pieces together. But you know what? You're not going to get it right away. I didn't get it right away either, to be fair, Bling. I didn't get this stuff right away. Remember, okay, I mean, I took a calculus class at U of I. I got a C. Okay, let's be honest here. And I showed up 30 minutes late to the final because I overslept. So that was que no bueno. All right. Guys, I told you before. I've been there. I've done that. Failed classes. Not done so hot. You know. Well, I'm not the greatest thing since sliced bread when it comes to being a math wizard. Um, it's just trying to put the pieces together one at a time. All right, let's move forward here though. Okay, so here we have x squared minus 9 and x squared minus 1. Now, important part here that's going to come up is what x is going to equal to. We set both of those equal to 0. X squared equals 9. Now, if we take the square root of this, x is equal to, what's x equal to? Square root of 9, ladies and gentlemen. Ladies and gentlemen, square root of 9. So he just says 3? 6? 6! 6! Nicholas, you're gonna scare the living pants off of me. 6. 6 squared is 9. What? Ooh. Ah. Ah. There we go. Something that we've learned here in this class. That is correct, Jess. The answer is both. Plus and minus 3. That is correct. So, once again, it is not just 3. We get 2 for the price of 1 for this answer. In this case here, we get x is equal to 3 and x is equal to minus 3. All right, so let's put a note here. Once again, plus or minus is in play. Okay. I am going to point that out here because, as I pointed out here before, sometimes it is and sometimes it isn't. And in this case, it definitely is. So we get plus or minus 3. That's going to be our answer for that. Second one here, x squared minus 1. So same thing applies here. Add 1 to both sides. Take the square root of both sides. And so here x is equal to plus 1 and minus 1. Ooh, I'll put 1 and comma minus 1. Okay, so if you notice here for x, we have 4 answers for x, okay? And each one of those x values is going to have a respective y that goes with it, all right? That's the goal, all right? So we found 4 answers here for x, 4 of them, right? Very important. All right, so let's take a look here at what we get here for each one of these answers. Now, some of these will repeat once again. And we could go ahead and use the substitution that we have here. If we go back to our guy, remember that y is equal to 3 over x, so you can use that directly in this case. Y is equal to 3 over x. So let's write that down again because we used that from before. So y equals 3 over x. All right. Let that keep going. All right, and so let's try 1 and minus 1. All right, so let's say x is equal to 1. All right, y is equal to 3 divided by 1. All right, so obviously this isn't too hard. You get 3. So x is equal to minus 1. Here we get y is equal to 3 divided by negative 1. Again, here we get negative 3. So here we get 1 comma 3. 1 comma negative 1 comma negative 3. Okay. And then we do the same thing here with 3 and minus 3. So x is equal to 3. So we get y is equal to 3 divided by 3. Of course, y is equal to 1. We get 3 comma 1. We get x is equal to minus 3. Y equals 3 divided by negative 3. We get negative 1. We get our last point here of negative 3 comma negative. All right, and these are our 4 answers. Again, we got 4 answers for this problem. Bada bing, bada boom. All right, that's the final answer for that. Any questions about that? Nice song, getting anime vibes. You should be. It's Toho Eurobeat. Should be getting anime vibes. All right, good stuff. All right, let's move on to the next question here. All right, so next question here is going to be about elimination. All right, now elimination, there's no difference in terms of elimination. The process is exactly the same. Now, there's not many looks for elimination because there's really, in all honesty, for elimination, there's really just kind of one type of problem, like 1 or 2 types of problems, really, that you're going to see for elimination. Really, technically, yeah, pretty much. Because the process is exactly the same, really. There's not a whole lot going on, in all honesty. So, but let's go ahead and do an example here for elimination. And you'll see, for elimination, as we've talked about before, it's really straightforward. We want to eliminate one of the variables, solve for that remaining variable, do the things. That's all well and good. Let's just go ahead and do one. All right. Let's just do it because, reasons. Okay. All right. So this is our guy here. X squared minus 4y squared equals negative 7. 3x squared plus y squared is equal to 31. Okay, fine. Okay, let's just choose a variable to eliminate. Let's roll with it. You guys tell me, x or y? Tell me what I should eliminate. Go. Bottom for y. We should eliminate y. Eliminate for y? Okay. Eliminate x? Alright, you guys choose. You eliminate x or y? You guys get your choice. Let's do a poll. It doesn't matter to me, so. X or y? X, y. I'll allow percentage points for vote. Here you go. I'm gonna test the system. Let me test the waters. 1 minute poll. Ba-bam. Let me test the waters here. Hey, there he is. There's E-Man. How you doing? Poll time, yes. You can use your channel points to add more votes if you want to. No, I'm gonna get a super surplus of votes for this one. You better, that's fine. Hello! go. Ooh, boy, look at this. Oh, man, it's a fight to the finish. Ooh. Ooh, this is getting close. Last 10 seconds. You better get those points in. Come on, come on. Is it 27, 24? 3, 2, 1. No, okay. Ooh, okay. X is our winner here. Jess contributed 525 channel points for X. Okay. X is your winner with 44 votes. Dang, okay. Alright, democracy has been shown. Alright. X it is. Alright. Let's eliminate X. My 300 helped. There you go. Khadijah's like, this is Sparta. Jess is like, no. This is Sparta. Okay. There you go. Alright. So if we eliminate X, what do we do? Tell me what I should do here. But how do I, but what should I do if I'm going to eliminate X? I got X squared on the top. I got 3X squared on the bottom here. Alright. That's okay. You can always pick up more points. Negative 3X squared. Okay, so yes, Brian. How do I get negative 3X squared on the top here? I agree with that premise. How do I get negative 3X squared on the top there again, Brian? Or anyone else for that matter? I'm the Monopoly man. What should I multiply that first equation by, guys? Let's go. Tell me what I should do. I multiply by 3? Oh, minus 3. Alright. Minus 3. Good. Multiply by 3, there's going to be lots of problems. Okay, trust me. That one sign, it'll make a huge difference. You multiply by 3, it's a disaster. I'm not going to lie. You could do it, but it's just going to be an abject disaster. Okay, so if you multiply by minus 3, we get minus 3x squared plus 12y squared. Story of my life. Oh, no. Oh, no. Now, why would you say that? Aww. Things are not terrible, are they? Oh, okay, that's good. I mean, here I thought I needed a fainting couch, you know. Here I needed a fainting couch to be like, oh, the math. Okay, you know. I've never heard of a fainting couch. You know, it's one of those one-armed couches, like you know. How does that look like there? See if I can. You ever see one of these type of couches? Yeah, like these type of couches. Like a fainting couch. There you go. One of those. Yeah. So it's got like the one arm on the side and that stuff like that. Yeah, it's a fainting couch. You just go and you're like, you know. Let me tell you, I don't have any of the fainting couches. All I have is a bed and a couch and a second couch that gets used for my keys to get thrown onto, and that's about it. The people like fainting couches aren't real. You're like, oh boy. You want to be bourgeois? Ooh. Let me tell you, if I lift up with my drink here, and I went ahead and I was like, I was like, yes. Lift up my pinky. There you go. All right. Pinky up. That's right. All right, let's get to it here. So we have negative 3x squared plus 3x squared. We've got to eliminate that. Here we get 13 y squared is equal to 52. Divide by 13 here. I think Brian is spot on here. So we got y squared here is equal to 4. Take the square root. And Brian absolutely is correct here. Y is equal to 2 and minus 2. Okay, so 2 and minus 2, absolutely spot on. Again, just like the last problem where we had 2 answers for the price of 1. Once again, we have 2 answers for the price of 1. Now, we just, again, do the same thing we did for the last problem here. Just go ahead, use any one of the 2 equations with our 2 answers here. We're going to solve for x. Again, you could get multiple answers, so be a little careful about this one here. So probably the easiest one to use, in my estimation, is going to be this first equation here. So let's see what happens with y is equal to 2. With y is equal to 2, we get x squared minus 4 times 2 squared equals minus 7. So let's see what happens here. We get x squared minus, this is 16. So we have 2 squared, which is 4. 4 times 4, which is 16, equals minus 7. Add 16 to both sides. And so here we have x squared is equal to 9. Take the square root of that. And here we get x is equal to 3 and minus 3. So what that implies here is that with y is equal to 2, all right, we are going to get 2 answers here. We got 3 comma 2 and negative 3 comma 2. And just repeat the process here with y is equal to minus 2. If you'll notice, what will happen here with minus 2 is that you're going to get the same exact steps here. Same exact numbers. The only number that changes, of course, is 2 to minus 2. But it actually effectively changes nothing, because negative 2 squared is positive 4. So here you still get the 16. Still get the minus 7. Still get the x squared is equal to 9. And still you get the same x is equal to 3 minus 3. So in this case here, you also get 3 comma negative 2, negative 3 comma negative 2. So here, as you can see, we get 4 answers once again. All right. Any questions about that? Would it be 3 comma minus 2? Yeah, I have that here, right? 3 comma minus 2. No, I have it. I have 3 comma minus 2 and minus 3 comma negative 2. I also have 3 comma 2 and negative 3 comma 2. Yeah, so I get 4 answers here, Brian. Because again, with each y, I found 2 x's. So that's why I have 2 points for each. Okay. Any other questions before we move on? All good? All right. Good stuff. All right. So for the most part there, that is section 5.4 in pretty much a nutshell. All right, so nothing too crazy going on there. That's pretty much kind of what I wanted to go over for that. Okay. All right. Okay. Let's go on to the last section here. Alright, so let's go over question 1 here, which is section 5.5. Alright, and then we have a possibility of going on to section 6.1 for next time, but we'll see how we get along with this. Maybe we'll do an example here today, we'll do an example here next time, whatever. In any case, we've been talking about systems of linear equations and nonlinear equations here. Now, in the last section here of chapter 5 that we're going to cover here, we're going to talk about linear and nonlinear inequalities. And we need to go ahead and graph the system of linear and nonlinear inequalities. All right? So what I've set out here is basically a set of steps here about how to graph linear and nonlinear inequalities. Bringing it up here on the screen. Yes, we'll be looking at matrices in chapter 6. Let's go ahead and go to question number 1 here, which covers the entirety of 5.5. These steps here will cover everything that we need to know. Is how do we graph a system of linear and nonlinear inequalities? All right, so let's do an example. We're going to follow these steps down the line and get this stuff done. Promise you, it's not as bad as it may seem. It just takes a little time to do. So they gave you some basic problems right away, but I'm going to skip right to the meat and potatoes, and I want to go ahead and do that. So meat and potatoes right away. Let's do the tough stuff and get it done. I must have the meat and potatoes. Now, for this process here, let's go ahead and start off with an example with a system of linear or nonlinear equations. Let's start off with something easy, and then we'll work our way up. Okay? So, yeah, why not that one? And I'm going to modify this a bit to make a point. So, okay. All right. So this is our problem here. Okay, so we have x minus y bigger than or equal to 4. X plus y is less than 6. All right. Our goal here is to graph this solution set. Now remember, we're not solving for x and y here. Understand that, because now we have an inequality. We do not have an equals sign here. We're not solving, say, x is equal to this and y is equal to this. That is not what is going on here in these problems. What is going on here in these problems is going to graph the solution set. Okay, that is what we want to do. We want to graph the area that would reflect, that would match this particular system of inequalities. So let's go through the steps here carefully about how to do that, and we'll see exactly how this works out. All right, let's go to step 1. Step 1 is we need to put it in an easier format here. In order for us to do that here, we are going to change those inequalities to equals here. Again, we're not solving for x and y, but again, to make it easier on ourselves, let's change that to equals. There you go. We have x minus y equals 4, and x plus y is equal to 6. All right, no problem. Step 2, solve for y, if necessary. Now, the reason why I say if necessary is because of this note down here. Sometimes we'll be given equations of circles centered at a particular value. Sometimes they'll be centered at the origin. Yeah, that's more for the nonlinear side. Equals is pretty much necessary for linear equations like these. So linear, you know it's linear because there's no x squared or y squared or stuff like that in it. So if there's no x squared or y squared put in there, then you know it's going to be linear. But we want to solve for y in both of these cases. Let's do that. So we're just going to go ahead and subtract by x here for this first one. Minus y is equal to 4 minus x. I'm going to subtract by 1. Oh, not subtract by 1. Divide by 1, negative 1. Pardon me. And so here we have minus 4 plus x. Okay. All right, so that's the first equation. We'll do the second equation as well. Solve for x in that case. We'll just subtract by x on both sides. Very simple. We get y is equal to 6 minus x. Okay. Alright, so y is equal to negative 4 plus x, y is equal to 6 minus x. Alright? So, alright, so now let's go ahead and do an xy chart here for each of them, because that's what we're going to do here for step 3. Now that we found both of those equations here, we'll make an xy chart to determine some points and graph using the following conditions here. So now I want you to take a look at this carefully. All right, so we're going to use the dotted line for the graph if we have strictly less than or strictly bigger than, or a solid line for less than or equal to or bigger than or equal to. So this is going to rely entirely, okay, this is going to rely entirely on our original inequality. So we're just using, again, the equations here to go ahead and graph, but now we're actually kind of leaning on the inequality here in order to determine what type of line we're actually going to put on the graph. So let's first make our little XY chart here, and then see what we can gather. Okay, so to paraphrase here, if we try a little XY chart, we plug in 0. Plug in 0 here, we get negative 4. Plug in 1, we get negative 3. Plug in minus 1, we get negative 5. Alright. Alright, so those are three pretty easy values. And we could put that on a graph, so let's do that. This is for, by the way, y is equal to negative 4 plus x. Sorry. Should have been a little clearer there. Alright, so let's put that on the graph. Now, to get 0 comma minus 4, so comma minus here. Negative 1 comma. Okay. Alright, so now here's the question. What kind of line am I going to draw here? Am I going to draw a solid line, or am I going to draw a dotted line? Am I going to draw a solid line, or am I going to draw a dotted line? That's the next question here. Solid or dotted? It says dotted, solid, solid. Josie revises her answer, says solid. Why is it solid? Guys say it's solid, but why? Okay. That's good. Okay. Both answers here absolutely correct, okay? Okay. Greater than or less than, that's one of those two. It has to be, it's greater than or equal to here in this equation. So specifically for this one here, it says greater than or equal to. So because it says greater than or equal to, that is correct. We are going to put a solid line here, and a solid line here all the way through. There we go. So there's our solid line here for this particular equation. All right. That's the first one. All right. Now we need to do the other one here as well, by the way, so I haven't forgotten about that. We need to do an XY chart for 6 minus x. Let's do that here, and let's see what we get. We'll just do the same numbers here. The 0, 0 you get 6, 1 we get 5, and minus 1 we get 7. Okay. For lines it's actually pretty easy, so 2. See? 1 and 5. 7. Okay. Now, based on what you see here in this instance, now that we have that, what do we have here? Are we going to have a solid line or a dotted line through those 3 points? A solid line or a dotted line here? We have a dotted line there. Okay. Are we sure? Dotted line? Okay. All right. I'm going to put a dotted line then. Yes, positive. Okay, good. Making sure. All right. So we're going to tell a dotted line here because it's strictly less than, okay? Because it says strictly less than here, then we're going to put a dotted line here in this case. Let's put a dotted line. We'll put it in purple here. It goes all the way through. Okay. So as it stands right now, this is the graph that we have here after step number 3. Okay, so we have one solid line, all right, just like so. And we have one dotted line, just like so. All right, that's what we got. All right. So far, so good. All right. All right, so I'm going to mark, I have the first line here marked in black. The first line here marked in black is 4 plus x. Okay, so negative 4 plus x. That's here in black. And here in purple, that's going to be our 6 minus x. So, purple. All right. So just pointing out here what the, again, different lines represent here because we're going to come back and use them. Okay. Let's take a look at the final step here. All right. So do the 0, 0 test to determine where you need to shade to determine your final answer. Now, we need to elaborate on this 0, 0 test and what this is talking about. So, 0, 0 test goes like this. Using your original inequality, we're going to plug in x is equal to 0 and y is equal to 0. Again, I always use the original inequality because there's less confusion to be had. Okay, so we're going to do the 0, 0 test here, and to remove the amount of confusion, I'm going to have that here. Step 4. Okay, hang on, can't see that. Maybe. Alright, so let's do the 0, 0 test. So I try it off with the first inequality, x minus y is bigger than or equal to 4. Okay. So all I do is plug in 0 in for x and 0 in for y. And I see if this is true or not. So 0 bigger than or equal to 4. So basically, it's going to come down to a true or false type of question here. You plug in 0 for both x and y, and then you just have to ask the question here. Is that true or false? All right, so let's take a look at what we have here. We have 0 bigger than or equal to 4. Is that true or is that false? Is 0 bigger than or equal to 4? True or false? False, finally. That is correct. Okay, that is false. Okay, absolutely 1000% false. Okay, that is definitely false. Okay. Okay, hit F to pay respects. All right, so it's That's what we have here. Now, if it's false, all right, let's talk about what happens if it's false. Oh, come back here. So false means is that if the resulting inequality is false, then shade the side that does not include the point 0, 0. Now, we have this first line here is for the black line, okay, for negative 4 plus x. All right, we want to shade. Notice that just looking at the black line here, ignore the dotted purple line for right now. Okay, we'll come back to that in just a second. But notice that there are two sides to this black line. Either A, you can shade above this black line, or you can shade below this black line. Again, we want to shade the side that does not include the point 0, 0. Now, the reason why we pick 0, 0 in specifically is because 0, 0 is very easy to identify, right? We know that 0, 0 here is smack dab right in the middle of the graph, okay? It's really super easy to look at. Like, you don't really have to guess. So, where we're going to shade right below, right here. Okay, this is where we're going to shade. We're going to shade below that black line, okay, because that's the side that does not include the point 0, 0, since we got false here for that first guy. Are there any questions about that before I move forward with the next half of this last step? Let's do the last part here then, with the shading part, and then we'll see what the final answer is. We have x plus y is less than 6, so let's go with that. So we're just going to go ahead and sorry. All right, so we're just going to put 0 in for x and y. And we say, is 0 less than 6? So true or false, 0 is less than 6. Is that true or is it false? Is 0 less than 6? All right. All right, so the answer is true. All right? The answer is true. All right, I'm going to roll with that. It is true. True. Bruh. I mean, I see new things made up every single day. I'm just kind of following your vocabulary here, going with it. Bruh, Medea. Medea says. Okay. Anyway. All right, so that's true. So because this is true, all right, then we want to shade the side that includes the point 0, 0. All right, we want to shade the side that includes the point 0, 0. So we're looking at the dotted purple line here. Okay, that's what we're looking at here, the dotted purple line. So because we're specifically looking at the dotted purple line, we're going to shade the side that does include this point here of 0, 0. I'm going to shade everything here that includes the point 0, 0. And as we can see, there is a place where the purple and the black overlap, okay? And that is going to be our solution set. So I will circle that in red, and that is going to be this area right here is going to be our solution set to this particular problem, right? So where these two things overlap will be our final answer for our solution set. Okay. Now in the homework there, for the online homework, they'll have a little paint tool in which you go ahead and click on the paint, and it'll, like, you have to click which region where it would overlap, and then you can figure out what that answer is going to be. So that'll be like that last part that I'm doing. So, but there you go. That is what you got. And that is the answer to the first type of problem here. There you go. Any questions about that one? Yeah, let's do that one. Yeah. Oh god. Is that okay, that's fine. No, that's all the steps we need? Yeah. Well, I wrote out the steps, right? Those are the 4 steps that I have pointed out there, I promise you. I mean, if you want more steps, Jess, I can certainly make it harder, but I don't think I would want to do that. I don't think you'd want that either. Be like, oh, yeah, that's it. Be like, yeah, that's all you need. That's what you wanted. Okay, then what you got? Okay. I try to give the people what they want. I'm like, I don't know I don't know how much further I can go. All right. Let's go ahead and do another example though. Another example needs to be done. I do need to do this next example here. I will be able to finish at least with this part. So, okay. So this next example here will be just a slightly non-linear example. So I'm just going to guide you through this one here because this will take up the rest of the time here. So let me go ahead and guide you through this one as it is kind of a double non-linear example. There is one case here where you do have a linear and a non-linear mixed together. This one has a 2 non-linear example, so I want to show you this the slightly tougher one here, and we'll go ahead and wrap it up. So, all right. So for this one here, we're gonna have x squared plus y squared less than or equal to 1. Y minus x. Okay, so this is our next example that we're going to do here for the remainder of the class. All right, so x squared plus y squared less than or equal to 1, and y minus x squared is bigger than 0. Now, in this instance here, what we want to do is we want to go ahead and go through the same steps that we did from before. All right, so nothing's really going to change here. In this regard, we're going to set them having equals. Okay, so we have y minus x squared is equal to 0. All right, so change them over to equals. That's perfectly fine. All right, now step number 2 is where things certainly change. In this particular instance, we have to solve for y if necessary. Now, one of the things that they like to throw in this particular section is they're like, okay, sometimes they'll throw you something like this, like x minus h squared plus y minus k squared equals r squared, which is the equation of a circle. And that's what this guy here represents. X squared plus y squared is equal to 1. Let's talk about that here. This is basically going to be, you just have to recognize that this is a circle having a center of, in this case here, the center is going to be 0, 0, and has a radius of 1. Again, why does it have a radius of 1? Because this equals r squared, and r squared is equal to 1. All right, so you'll just have a radius of 1 here in this case. If this was, let's say if this was a, let me show off one thing here really fast. If, oh, I can't see that. Oh. Put it up here. If you have this here really quick, if you have this equal to 4, the radius here is equal to 2. I just want to point that out. Radius here equals 2 because the square root of 4 is equal to 2. Alright, so it's r squared. Alright, just pointing that out there. In any case, the second one is probably where we need to solve for y. We have y minus x squared is equal to 0. Simply just add by x squared on both sides. And so here we have y is equal to x squared. Now for the first equation, we don't need to go ahead and solve for it because we already know it's centered at 0, 0, and it has a radius of 1. I'll show you how to actually do that out here in just a moment. But we can easily find y is equal to x squared as a guy. Again, you have 0, 0, 1, 1, negative 1, 1. Okay. Most of you are fairly familiar about x squared. Again, a parabola. Really nothing too fancy going on there. Okay. Now, the more important part here is the graph. So let's take a look at it. Okay. So what about the circle here? You're probably wondering about that. Well, the circle starts at 0, 0 here, and then we go 1 unit up, down, left, and right. So we go 1 unit to the right, 1 unit up, 1 unit to the left, and 1 unit down. So we go up, down, left, right from the center by that amount of units, which is the radius. So for our circle here, specifically, I'll put it in red. That's going to be x squared plus y squared equals 1. So that's just reflective. Doesn't actually hit the point 0, 0. We just use it as the center of the circle. As for y is equal to x squared, that's pretty self-explanatory here. So y equals x squared here. We'll put it in black. We'll have it at 0, 0 here. We'll have 1, 1 here. So this is 1, 1 is up here. Negative 1, 1 is over here. So again in black. Now in this case here, oh yeah, right, dotted and solid. The circle here was solid because we have a less than or equal to. And then because this is strictly bigger than, our parabola here will be dotted. So we're going to have a dotted parabola. Okay, so there we have a solid circle here for x squared plus y squared equals 1, and a dotted parabola here for y equals x squared. So again, because of the inequality. All right, so before we move forward here, are there any questions about the preliminary graph before we do the shading part? A couple parts that we'll need to talk about there. This particular example, just need to be really careful. So I just want to be sure that everybody's on board. Okay. Okay. So how do you know if you'll have to do the radius? You always have to do the radius. The radius is always on the right-hand side here, Fritz. So if it equals 1, or it equals whatever, it's equal to that r squared. Just take the square root of what's on that right-hand side, Fritz, and then that's the radius. So there'll always be a radius to a circle there, Fritz. It just depends where you start from in terms of your center of your circle. Does that make sense? You always have a center and you always have a radius, no matter what. Just making sure that we got that down. Any other questions? Fritz, does that make sense? I want you to let me know if that's okay. Or if you need me to clarify something. We don't have a circle in the last problem there, Fritz, because we have to have it in this form here. So it has to be like x squared plus y squared is equal to r squared. Something like this. Okay, so the last example that we just had 2 lines. right? We had like y equals mx plus b. In this case, we actually have a circle here. Yeah, so that's the difference there, is that the last example, we didn't have an equation in that form. So we didn't have that there, all right? So I just want to point that out here. That's what it came down to. All right, cool. All right, next we need to do the 0-0 test. Let's do the 0-0 test. That's the next part here. So the 0-0 test here, we're going to do the 0-0 test with the first inequality. Again, you have to use the original inequality. So x squared plus y squared is less than or equal to 1. Let's do that. So here we have 0 squared plus 0 squared is less than or equal to 1. So true or false, 0 is less than or equal to 1. Is that true or is that false? That is definitely true. That is true 100%. So because this is true, we're going to put this in red. Actually, no, we're not going to put that. Yeah, we're going to put that in red. We'll put in yeah, put in red. We're going to shade the side that includes the point 0, 0 because it is true. So everything here in red, 0, 0 is right smack dab in the middle. So it's everything on the inside of this circle here, at least in this case. Okay. Now, the next one here is y minus x squared is bigger than 0. Now, here's the issue with this one. The problem with this one is this, is that 0, 0 is on the actual graph. So unfortunately, we can't use 0, 0 here in this case. So I put this important note here because I wanted to be sure that you guys understood what you needed to do in case if this happens. And this can happen because some lines do just touch the origin there at 0, 0. So if the line or graph contains the point 0, 0, use a point not on the line or graph and repeat the test using that point. Okay, so that's essentially what we want to do here. Let's just pick a point that actually is not on that parabola and then go ahead and see if that happens to be true. So let's pick a point here. In this case, instead of using 0, 0 because 0, 0 is on the parabola, let's use a point here as 1, 2. Okay, I would normally put 1, 1 here, but 1, 1 is also on this graph here. So, but I know for a fact that 1, 2 here is not on the parabola. So as long as I can pick that, then I know that what I need to do here. So 1, 2, if you want to know, is up here. Okay, so this is what we're doing. Okay. Now, so I plug in x is equal to 1 and y is equal to 2. So I click 2 minus 1 squared bigger than 0. So that's 2 minus 1 bigger than 0. So now the question is 1 bigger than 0? That's the question here. Is 1 bigger than 0? That is true. Okay, so that is going to be true here. So again, with the parabola here, okay, just be a little careful here. You have everything inside the parabola and you have everything outside the parabola. Okay, so inside and outside. So we want to shade the side that includes this point here of 1, 2. And 1, 2 is like right here, okay? It's like this point right here, right where my mouse is hovering. So I want to include everything inside this parabola here. I want to shade everything here in black, okay? Nothing outside the parabola, just everything on the inside of that parabola, just like so. Otherwise, it'd have to be everything outside. And so we just take a look at which parts here overlap. And at the end of the day, what overlaps, but as you can see here where the red and the black overlap, it happens to be this area here circled in purple. That little area there would be our solution set for this problem. Okay, so this one here is a little bit tough because outside inside can be a little bit tough to look at. And again, we have to make the adjustment to the 0, 0 test since 0, 0 is on one of our pieces of graph. But I wanted to showcase this problem off here so you know how to attack those problems if you do run into this issue. And again, that's where the important note here that I put down is very valuable. All right. Can't wait for this homework. Man. Just wait until this test. These problems will appear on the test. True. Yes. Is this everything for 5.5 or is there more? No, that's pretty much it, Nicholas. That pretty much it. That pretty much is it for section 5.5. I chose the point 1, 2 because that is not on the graph. That's why. You can choose any point that's not on the graph. So does that mean the test is coming? I think you should look at the current state of affairs, my good sir. First few minutes of class here. I think I'll just go ahead and show you here, my good friend, that if I go back to my main menu here, all the tests have been posted, including the final exam. So everything has now been posted. Yes. Yeah, I want to give you as much time in order to do everything out. So again, you have 23 days from now to get everything done. So now everything is posted and ready to go for you to go ahead and attempt. All right. So everything now is out and about. Again, as I mentioned here earlier, if we do not get to Chapter 8 material, then that will be omitted from the final exam and the homework. So, and the regular test, of course. So, that's if we do. Right now it's on there, but I could easily just strike out the questions. Any other questions? Any other questions, ladies and gentlemen? Nope. Okay. So I do want to point out one thing here for tomorrow. Everybody, before you decide to step on out. Please bring your graphing calculator with you tomorrow. We're going to be using that rather extensively. So again, be sure to go ahead and bring your calculator with you tomorrow. Using that for several examples here as we continue moving forward, okay? I just want to point that out so that way you're not caught unawares. All right? All right, so calculator usage quite heavy tomorrow. So just want to be sure everybody is on the same page here, and we should be good to go. All right, ladies and gentlemen, thank you very much here for coming on iAgent Stream once again. You're out of time here for today. All right, but I want to thank you all. All right, all of you, absolutely fantastic. All right, we're going to come back here. We're going to get started here with Chapter 6. That's what's on the agenda here, Chapter 6. All right. Chapter 6 is, I think, a little bit lighter material then chapter 7's like the super heavy material, and then we'll see if we get to chapter 8. All right, so all right, everybody, have yourself a very wonderful afternoon/evening. Have a great day. All right, we'll be back same time, same place tomorrow. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right, have yourself a great one, everybody. Take care of yourselves. See you tomorrow. Take care. Bye. Remember, I'm on Discord or my email. All right, if you have questions. See you guys.